I am going to talk to you today about the M and C in MVC. So it probably would be better titled An M and V and C in MVC, because this is just like one idea which I use and been using for the past year, but it's not the one and only way of doing it. But anyway, I'm going to start with a really contrived example, because that's a good way to start a talk. So let's say we want to display some invoices in an app. Maybe we're going to try and write a Salesforce killer or something like that. And we're going to store them with Redux. So hands up here, who uses Redux? A lot of people, that's good. So you might be able to follow what I'm talking about. And we're going to inject them into a component with Connect. So who uses Connect with Redux? Cool, so a reasonable number of people. And the way we're going to store them is we're going to have like a global store of invoices. So we're going to have all of our invoices in there, kind of like a cache, everything that we've read in from the server. And we're just going to pull out the ones that we want and put them in the component. So another thing we'll say about this example is we're going to have like 10,000 invoices. So we can't render a list of 10,000 invoices, or we can, and the users will get really annoyed because like it'll take about 5 seconds to render. So we're going to need to virtualize the list, which means instead of just rendering like 10,000 components, we're going to render like a div and a scroll bar, and we're going to capture the sort of position of that scroll bar and only render like 20 or 30 invoices depending on where the scroll bar position is. And to do that, our scroll bars are going to generate a limit and an offset. So who here knows SQL? Okay, it is a React conference, so I probably shouldn't have hoped that everyone would know SQL. But limit and offset is it's like if you do Java an array.slice, you start with an offset and then you have a limit. So it's just that's a way of using two numbers to define that window. So if you've got 10,000 invoices and you do offset 20 and limit 20, then you're going to display 20 invoices starting from the 20th one. And we're going to store those numbers in component state. So that's a bit of a mouthful. It's maybe a little hard to understand. So let's have a look at some code instead. Here is what our container is going to look like. So how many people know the difference between a container component and a presentational component? That's awesome. That's really good. So this is just a container component. It has state. It doesn't render any DOM elements. It doesn't have any style. And InvoiceList that we're rendering there, that does have style, and it does render DOM elements. And we don't have to really worry about what that does. All we need to know is that that takes a bunch of invoices and renders them. So that's the container which holds our state, which is where we're actually looking at, which part of the list we're looking at. We'll just assume that there's some virtualization component which keeps the state up to date. So how do we actually get the invoices that we want to pass into InvoiceList? That's what we use Connect for. So for those who don't know, Connect is just a way of taking a Redux store and returning part of that Redux store, and then injecting that part into a component. So the problem is, that we've got a container and it's got state, and inside that container we've got a presentational component which renders a bunch of data. But where do we put Connect? Like if we put it on the outside, which is the first thing I tried, and I think the most obvious thing, it doesn't actually work, because if we go back here, the Connect higher order component there, it needs to know about the offset and the limit in order to pick those 20 or so invoices out of the store. But it doesn't have access to the offset and the limit because that state is stored inside the Connect component. So if we have a look in this sort of diagram here, if Connect is on the outside of the container, then we can't access the state inside of the container. And that's a big problem, because it means we can't really reuse these containers with Connect. So it makes it a lot harder to write reusable containers, which we can use within different parts of the application. So this is a problem I ran into while I was building an application for a customer, and that's where the idea of controllers came from. But before I got to controllers, I thought, okay, so why are we going to use SetState at all? Like, why are we going to store this state in component state? If we're using Redux, why don't we just store all of our state with Redux? I think I've met a few people who do it that way. It's certainly possible. We could put the limit and the offset in the Redux store, and then we'd have access to that from anywhere, and we wouldn't need to worry about all this. So there's a few problems with that. One is, once you've got multiple container instances, say you want this InvoiceList container in a few places in your application, how do you know which part of your Redux store to get it from? It's possible to make different parts of your Redux store for like different instances of that container, but that really removes the advantage that you have from React, where you have these reusable components. Because once they're linked to a certain part of your Redux store, they're not reusable anymore. Another issue is that if you're using Redux, then you can't do a partial update. Like every time you dispatch an action to Redux, it computes the entire store again using the reducer. And that's okay if you've got like a small focused reducer, that if every single view in your application gets its reducer called every time that you hit a keystroke, then once you've got an application with like 100 screens, then you actually get a visible delay between hitting a button and keys coming up. And then you get users coming and complaining to you, like, why is this slower than before? And it's not very fun to deal with, even if you, like, I write internal software, so I've got a captive audience and I can tell them, well, deal with it. But not everyone can. And the last issue is that SetState only renders one part of your application. So if you change the state, it only re-renders everything underneath of that. Whereas with Redux and Connect in particular, if Redux needs to re-render because, if Redux gets a new state because the reducer has been run, then every single connect that is on the screen at that point in time is going to re-render from the start. And that can quickly get really, really slow. So I think instead of putting all of our state in Redux, which you can do, it's best to use SetState for this kind of thing. And that's why React was designed that way. But so we want to use SetState, but we can't have the state inside of our Connect component. So I guess the thing to do is try to move the state outside of the Connect component. Here is our InvoiceList container again, the same container I showed you earlier. The only difference now is that instead of rendering the invoice list directly, we render a sort of connected invoice list, which is an invoice list which has that connect decorator applied to it. And that fixes the problem. I mean, this works now. All we've done is, in the hierarchy, we've swapped connect and the wrapper container. So all of the state is in the wrapper on the outside. And then that state gets passed through to Connect, which can use that to select the data that it wants. And then that selected data gets passed through the presentational component. And OK, that works. It's all good until you want to do something like fetch an invoice. Like you want to make a request to the server when you don't have the data that you need. And then things go all wrong. So the problem is we don't actually have all of the data. We don't have all 10,000 invoices in our store because, I mean, depending on how you store them, you might be able to fit 10,000 into a store, but it's going to be slow. So what we do is we get one at a time. So let's say you've just opened this invoice list. It's probably going to have, say, 20 or 40 invoices already cached, but it's not going to have all of them. And so when you hit next or previous on your pagination, you don't actually know if you have those invoices that are in the next 20 or the previous 20 until you check. Now, what does checking look like? This is something that looks pretty similar to how I actually check or have checked in the past for whether I actually have the data in the store or not. So need to fetch is just a function which has a look at the stuff that's been passed into the component and it's really pretty simple. Like if the data doesn't exist, then you dispatch a call to the server to get it. Now you put that in a lifecycle method, so every time the component is mounted, it fetches the data if it doesn't have the data which it requires. Which is simple, but like where are we going to put this lifecycle method? Like on the outside, we have our state, and then we have our connect wrapper, and then we have our presentational component. So this needs to be inside the connect. This needs to be inside that connect presentational component thing. So we're going to have to actually add another layer to it. So let me see. We're going to have to add, like, between the connect and the presentational component, we're going to need to add another wrapper. So we've got like 2 wrappers and a connect higher order component. And it's like, if you actually think about how we're going to name all of this, maybe we'll have, I don't know, invoice wrapper container, and that renders the connect higher order component, and then that renders the invoice inner container component, and then that renders the sort of InvoiceList component. And if we're a Java programmers, this might be okay, but it's like really, really long names and hard to deal with. But pretend we're Java programmers for the moment, and we can deal with the long names. It's still really ugly, because the problem is that having all of these different container components just to render something really and fetch some data, it has, as well as being ugly, it also means we have to run a lot of render functions. The big problem here is that when you dispatch an action using Redux to fetch the invoices, which you don't have, what that's going to do is it's going to go back to the connect, and it's going to re-render everything within that connect. So having a look at the flow there, first you render the wrapper container on the outside, then you render the connect component inside of that, then you render the inner container, and then it goes, oh, we don't have the data we need, let's dispatch an action. And then that triggers the connect component. When you go back and you render that again, and then you render the inner container again, and by the end of it, like, all you wanted to do was display an invoice list, and you don't even have any data yet, and you've gone through like 6 render functions. And you think, okay, but that's okay, because 6 render functions, we can deal with that. But it's only 6 if you've only got 1 connect. If you start composing connects, and you have like, I don't know, there's 2 here, because that's all that fitted on the slide, but I've had like a really bad API that I've had to deal with, where I've had like 4 different connects. And it gets really, really messy. Like, instead of, like, if you only have 1 connect, you have about 5 renders. But it doesn't scale linearly. If you've got 5, so if you've got 2 connects, instead of just having like 1 extra render, it starts looking like this. Like, you have a wrapper container on the outside, which holds your state, and then you have a connect component for the invoices, and then you have a connect component for the contacts, so that's 3 renders, and then you have the inner container, and then you say, okay, we don't have the invoices we need, so let's fetch them. And then it jumps back up to the connect component again. And then it renders everything until it gets to the inner container again, and then it says, okay, we don't have the information for the contacts, so we need to fetch the contacts. And then the flow jumps back up to the connect again, and it just, like, if you have 4 of these connects, I think you'll probably get like 30 render calls before it renders anything. And it actually gets really, really slow. Like, so slow that you get complaints from your users. So really the problem is this container presentational component pattern. It's really good, but it doesn't really work with composability. You can't use connect outside of your container components multiple times. Like, you can't stack them and then hope that you're going to have performance as well, because it just doesn't work. So after running into that, I tried a few different things, but the one that really worked is something I call controllers. So controllers, just like containers, they are for dealing with state. They don't actually render any DOM stuff, but unlike containers, they don't render anything at all. So the responsibilities to manage the state, so that you set an initial state and you change the state with a SetState method. to select the data. So that's the same thing which Connect does. They don't render anything, like I said. And two other important things here, which I'll get to later, that controllers have exclusive control of any side effects. Like Connect leaves the side effects to the component which it wraps. If you have a Connect higher order component and you inject some data and that changes, then you need to watch that data with lifecycle methods and then make the side effects work that way, whereas a controller manages those side effects itself. And the other thing is that a controller will wait for side effects before it continues. And that's really important, but I'll get to why that is later. So let's have a look at a couple controllers. The first one is Connect. And this might be a little confusing because I was saying that Connect leads to performance issues, and then I tell you the controllers fix the performance issues, and now I'm saying that Connect is a controller. Why is that? Is that Connect is a really simple controller when you make sure that there are no side effects. So if all you want to do is select data from the invoice store, or any store, and you don't want to actually fetch any data if it doesn't exist, you don't want to cause any other side effects other than rendering something, then Connect is a really good controller. It's just, you shouldn't use it when it does things other than just select some data from the store. So let's have a look at another controller. This is kind of more a theoretical controller. It's something very similar to the one I've been using, but it's simplified a little bit. In fact, it's not one controller, it's a function which can create controllers. So you can kind of think of this CreateController function just like React's createClass function. But createClass returns components, and CreateController returns controllers. So how we would use this, or how I use it in practice, is I pass a bunch of options to CreateController, just like you'd pass a bunch of options to CreateClass. And then the thing is, like, a component is a component, whereas a controller is closer to a higher order component. So we need to apply those controllers to a component. Here's one example where I've got an InvoiceList controller, and I just apply it to InvoiceList screen with a control higher order component. But you can actually add multiple controllers to one component. So what are the different options that you can pass to CreateController? The simple ones are state. Just like with a React container, a controller has state. So you can pass the initial state, you can pass in actions, which is just like the method you'd have on a React component, and those actions can change the state using a SetState function. But you might notice that I've got here a yield and that star to make a generator function. Why is that? It's important, I'll get to it a little bit later, but just want to point that out, that the actions in controllers are not just normal functions, they're actually generators. So what other options can we have? We can have a connect option, and this is basically exactly the same as the configuration you'd pass to the connect higher order component itself. And so this is just a way of selecting some data from the store and injecting that into the component which the controller is applied to. And the other thing that you can have is you can have basically lifecycle methods. So just like React has lifecycle methods, a controller can have lifecycle methods, except instead of reacting to changes in props, they react to changes in the selected data. And you might notice that the lifecycle method I've got here is a generator as well. Just keep that in mind. It'll make a little bit more sense in a moment. But before I get to why the generators are there, this talk is supposed to be about two things. It's about controllers and models. So I'm going to talk about the model a little bit, which I think will make this make a little bit more sense. So if a controller is something which manages your state, then the model is the state itself. So far, you've heard of two types of state. You've heard of the state which is stored with Redux and the state which is stored with SetState. Actually, as far as I can tell, there's 5 types of state in a React app. There's data, there's communication, there's control state, there's environment state, and there's location. So I'm going to go into a little bit of detail on what those 5 are. So the first is data state. That's basically a business object. When I say your Redux store has a bunch of invoices or contacts or something else, that's data state. One of the things about data state is that each thing in your data state should be selectable by a type and an ID. So if anyone here has used JSON API, it's a standard that the Ember guys wrote. One of the things you'll notice is that everything that is returned by the server has a type and an ID. I think that's brilliant, and I use that as well here. So everything in my data store has a type and an ID. And that's why I've got this bookshelf up here. Is basically, I think of it as a shelf. So you pick the shelf you want, which is your type, and then in that specific shelf, you'll have an ID, and you can pull out the object that you want. Another thing about data state is global. So if you have a bunch of invoices in a cache, it doesn't matter which component you access them from. They're always going to be the same. So it's global to your application. It's not specific to a container. And because of that, it works really well with Redux, because Redux is also a global store. So what does that look like in practice? This is something you might find in my Redux store for my data state. So you have an object where you can pick out a type, and then when you pick out the type, you'll have a map of ID to objects. And those objects basically contain a version of the data on your server at one point in time. One thing they don't contain is they don't contain status. So they don't contain things like receiving or creating or deleting or fresh or something like that. That's communication state. So communication state is basically the state which represents all the requests which are currently in progress or which have failed. Communication state, just like data state, is global. Basically, it changes every time a request in your application starts or stops. And it's stored with Redux as well, at least in my implementation. So hands up here, who's ever written this.setState is fetching is equal to true, or no one? Someone? A few brave people have said that they've done that. One of the things about having communication state defined this way is you don't have to do that anymore, because basically you combine your communication state, which is it's defined by the things which are in progress. It's not something which you have to imperatively change. And you combine your data state, and then you can say whether something is fetching or not. Here's an example of communication state. So this is an object which represents one request. It says we're selecting basically all of the invoices, and we hope that we're going to get a return value from the server, which is just a list of invoices. Another more complicated object representing communication state is here. This one, we're selecting a single invoice, but instead of just getting it, we're actually creating it. And we've also, in the operation value here, we're saying what we're creating. And we've also got an error which says it didn't work. So if you have this and you have your data state, then you can combine the two, and you can even, depending on how complicated the function you make to combine the two is, you can get optimistic updates out of this really easily. So these two are global. They both fit in Redux. The other one that you've seen so far is control state. The reason I call it control state is because it's basically the state of all the controls on your page. So forms, filters, orders, scroll bars, that's all control state. And it's specific to one component. Like, if you have one component, then its state isn't going to be valid in other components. Because of that, it makes sense to store with SetState, because SetState is specific to one component. And it just all works. One thing it doesn't include is information from the environment around the component. So that's environment state, which is basically just information passed in from the outside world. For me, that could be props in context, but there's probably other ways you could define that as well. And one of the things about environment state is you might think, okay, the environment is the environment, it's global, but it's not. It's specific to one component, because one component's environment in React might be different to another component's environment. So this is also local to a single component. And lastly, there's location state. Location state is probably the hardest to describe of them all. I sort of made a major cop-out and just defined it as the information stored in HTML5 history. So that's like the URL, any state stored in push state. But I think it's a lot easier to visualize this than to sort of define it with words. So if you have an application, if you see your application as a tree, and all of the possible components which can be rendered are this tree, then the ones that are currently rendered are a subset of that tree. So that's what this kind of diagram / picture here represents, is that the yellow part is your current location state, whereas the whole tree is the possible group of locations within your application. So, and I don't actually use React Router personally, but you could probably define this in terms of the current routes which are active with React Router. But the important thing is that you define it as a tree. So that are the 5 types of state, and you can sort of further categorize them into 2 different groups. So global state, which is your data and your communication. And that's global to the entire application. It's not specific to a single component. And then you've got your control, your environment, and your location state, which is specific to a single component or a specific sort of tree from that component. But if we can split them into these 2 types, why have I bothered splitting them into 5? That's because the side effects which each of the different types of state can have are different. So, for example, nothing can change data state directly. The only thing which can change data state is when you get some information from the server. So when a request comes back and it's completed properly, then that will change the data state. But that's the only thing which does. And because of that, you can make a bunch of optimizations in your controller logic, because you know you don't have to worry about some action that the user has made changing your data state. Another one is that nothing can change the environment state around it. So I think that probably comes out of the fact that I've defined environment state as props in context, because the component obviously can't change its own props in context. But if you define it differently, it still stays the same. Like, the environment is the environment. You can't change the environment unless you think about global warming, but let's not. So hopefully after explaining all of that about the model, the controllers might make a little bit more sense now. So here I've got up on the screen the connect option for that CreateController function. And if you have a look here, unlike the connect which you might be used to with React Redux, React Redux, React Redux just has a state argument and a props argument, whereas this has 5 arguments. It has data, requests, env, location, and state. And they correspond to the 5 types of state which I've just talked about. State here represents control state, but I've just called it state to match up with the fact that React components have a state property. And the whole idea is that this connect option specifies that we want to take the offset and the limit, which are part of the control state, and we want to use them to narrow down the data and request state to the parts which we actually want. So hopefully that makes a little bit more sense now. That's what the connect does. Now, in that list of arguments, we have env and location. I think control state, data state, and communication state are really quite well defined, whereas env and location are a little bit more iffy. You can do whatever you want with those, but I would say stick to props and context for env. And if you're using React Router, then you want the route object to be the location. But going back to the options for CreateController, so hopefully this is also going to make a little bit more sense now. Maybe not completely make sense yet, but controller will receive data, our lifecycle method. Basically what that does is every time the data selected by connect changes, this gets called. So that means that if your state updates, then the data selected by that select invoices function in the connect definition might change. And so this will get called. So unlike in a React app where updating your props changes this will update every time that your selected data has changed, not just the props of the state. But I still haven't explained what the generators are for. So that's the last part of this. Basically, they're for dealing with side effects. So what are side effects? They're things which happen when state changes. So if you, for example, have a post request because you want to create a new invoice, and that completes, then maybe you want to navigate after that. That's something which has happened to me a number of times. So that's one side effect. Another one would be if you're typing in something in a form field and you want to automatically fill out another form field, that's also a side effect. You're changing the state every time the state changes, as opposed to the first one where you're changing the location state every time the communication state changes. But the important thing is that side effects are things that happen when state changes. Last one I've got is you might want to make another request when one finishes. So that's communication state changes when communication state changes. And if you think about that, if communication state can change because communication state has changed, then that can cause an infinite loop, which is really kind of nasty. And this has happened to me a number of times. Unfortunately, it's happened at least once in production, where I've written something which should have worked, but it didn't, and ended up in an infinite loop, and I had users get really annoyed at me, justifiably. But if we go back, earlier on I showed you the render flow where we rendered one connect decorator, and we rendered 5 times. That could be a lot worse. Like, here is an example. This is probably the example with names changed from when I pissed off a bunch of users. If you dispatch a request for invoices, say we don't have any invoices, so we dispatch a request, okay, let's fetch our invoices. That will re-render the connect component because every time we make a Redux action, connect is going to re-render. And then that will render the container inside of it, which will see that new invoice data injected by connect, or the lack thereof, and it will say, oh, so there's no data. Let's make a request for the data, and then we go back up to the top and keep going and going and going. And I call that uncontrolled state. So any state whose side effects can cause an infinite loop is uncontrolled state, which is a really general way of defining this, because basically any state in a React app is now uncontrolled state. For example, if your location state can change because someone has navigated, like it does with a redirect, if you're not careful, then that's uncontrolled state. And if you can cause HTTP requests when your communication state changes, so if you have like a queue of different things to fetch, or if you fetch automatically when the data changes, or the communication changes, sorry, then that can be, well, that is uncontrolled state. And the thing is that uncontrolled state often looks really harmless. So if you have a look at this piece of code, there's nothing wrong with this piece of code. It should work. Connect will inject a bunch of invoices based on whatever is passed into it. And then that container inside the connect will have a look at the injected invoices, and it'll say, OK, we don't have any invoices injected, so let's make a fetch to get them. Which makes sense if select invoices is implemented correctly. But say you're on a team and you implemented it correctly, but someone else doesn't realize that it's used this way and they change it, and then suddenly it's an infinite loop. But it shouldn't be, because this is correct. But that's the problem with uncontrolled state, is if you can cause an infinite loop, at some point you will. And that's why side effects are kind of dangerous. And that's what the generators are for. So hands up, who here has used generators? A few of you. So I'm going to try and introduce them really quickly. Basically, generators are a way of pausing a function. So you have a yield statement. What that does is it pauses that function, returns control to whoever called the generator, and then whoever gets that control can then resume the generator, and they can pass in a new value which will be returned by yield. Here's an example. I might let you have a look at it later because running out of time, but basically that yield will pass control back to the little script at the end, which will then say, okay, here, have this world string, and then it will print it out. So it'll say hello world. So why are we using yield in our controllers? The reason we're using the yield in controllers is because it lets us pass control back to whoever called our controllable receive data method. And the way I put it is you unroll the loop. Like if you were using a standard React component will receive props method, then what's going to happen is that when you call this.dispatch or this.props.dispatch and you dispatch a new Redux action halfway through your lifecycle method, then it's going to trigger a re-render, and then it's going to get back and you're going to call controller will receive data again. So even though you're already halfway through controller will receive data, or you're only halfway through, it'll start again and again and again. That's a symptom of uncontrolled state. Whereas if you use generators and you use yield, then what the code managing your controllers can do is it can say, okay, we're already halfway through this lifecycle method, let's not start it again. And instead, let's finish off those side effects, generate a new state, and pass it in via yield, and we can continue. And so using generators, it's basically impossible to create these infinite loops. So it turns it turns uncontrolled state into controlled state, which is why I call them controllers. And one other thing is, so here we've got this.dispatch. That's not actually a dispatch. It doesn't perform an action. What it does is it just returns an object which defines an action. So instead of performing the side effect itself, it creates a message and tells the code managing the controllers to perform it instead. So we have 4 different types of messages we can pass back. We can dispatch an action to Redux. We can set state, which will set the controller's state. We can navigate, which is probably going to use React Router or something like that. And we can call one of the actions which we've defined on it. So just one more time looking over these controllers. Hopefully they make a little bit more sense now. Actually, maybe I don't have time for that. So yep, this is the basic summary. We've got 5 types of state. And controllers turn uncontrolled state into controlled state. So thanks for listening. And yeah.